Compounds and composition compounds have a definite composition. That means that the relative number of atoms of each element in the compound is the same in any sample. This is the law of constant composition, or the law of definite proportions. Electrolysis of water is the process of using electricity to split water, H2O, into its component elements, hydrogen, H2, and oxygen, O2. Because pure water conducts electricity poorly, a small amount of electrolyte, like salt or sodium hydroxide, is added. When a direct current, DC, is passed through the water via two electrodes, an anode and a cathode, a non-spontaneous redox reaction takes place. At the cathode, water is reduced to form hydrogen gas and hydroxide ions, OH-. At the anode, water is oxidized to form oxygen gas and hydrogen ions, H+.
Hi guys, this is a strange looking instrument called the Hoffman voltmeter. Let's just explain it. We have a source of electricity, direct current, and we've got positive, negative terminals attached to two terminals that are inside some water with a small drop of sulfuric acid just to allow it to conduct electricity. And the electricity splits the water molecule up, and we call that electrolysis, the splitting up of water. Electrolysis is the term we use for a chemical reaction induced by electricity. So the electrolysis of water is occurring. And you can see bubbles bubbling up in these two tubes. Now the tubes are there specifically to collect the gases separately. So let's have a look where the gas levels are at the moment. We've had enough gas to push this one down to there, and that's at the negative electrode. And we've had on the other side half that amount. And if you remember the formula of water being H2O, clearly this is hydrogen, and there's twice as much as the oxygen on the other side. Okay. To prove that it is hydrogen and oxygen, we're now going to ignite the hydrogen, and we know it makes that little explosion, the popping sound, and there we will see what it does to a glowing stick. So, to get the gas out, I put it in a test tube, and I slowly open this, and we will see the level of this liquid go up. As the reservoir drops, it pushes down and pushes the level of the hydrogen up. There we go. So this is pretty much full of hydrogen. Now we're going to go and take it and see what happens. The characteristic popping sound of hydrogen exploding. On the other side, we're going to try and collect the oxygen. Right. Well, while we get that ready, let's just ignite the glowing splinter. Now I blow the splinter out, and I'm going to put it into the tube that's got the pure oxygen in. Can you see there? Oxygen supports combustion, and it made it not only glow brighter, but actually burst into flame. So pure oxygen will make a glowing splinter ignite and burst into flame. To contrast that, I want to show you what happens when I stick a glowing splinter into a tube full of air. You can see it just snuffs it out pretty quickly. It certainly doesn't glow brighter or ignite.